Today we're looking at lesson 1-3, which is on distance, finding distance, and finding midpoints. And there's two ways to find the distance or the midpoint, and that would be on a number line or a line segment, and then on a graph or a coordinate plane. So we'll look at both ways and the formulas that go with each one. This is the distance formula. This is pretty simple if you think about it. If you take 2 points or 2 values, one at P on this line and one at Q, you would take those 2 values and subtract them, but then think about them never being negative because it's distance, okay? So that's why we put absolute value symbols around the x1 minus x2. So let's say you had P was 6 and Q was 9. You would do 6 minus 9, but obviously the distance is not negative ever. So you do the absolute value of 6 minus 9, which would be positive 3. Here we're just looking at a number line and we're going to find AC, CF, and FB. So if we're finding AC using the formula, we need to take negative 7, subtract negative 4, but then it's going to be the absolute value of that. So negative 7 plus 4 is negative 3, but the absolute value of negative 3 is 3. So the answer is 3. If we're doing CF, we would put negative 4 minus 5. And again, if we did the math, negative 4 minus 5 is negative 9, but the absolute value of negative 9 is 9. And then FB, oops, you're going to take F, which is 5, minus negative 6, which is B. The absolute value of that is going to be 11, and it's positive 11 already, so that is your answer for FB. Now we have the distance formula on a coordinate plane, and you're going to be using this formula, which we'll see a lot, and this is using coordinate points or coordinates on a graph. So if we use the formula, they give us 2 points here. The formula to rewrite is x1 minus x2 squared plus y1 minus y2 squared. So if we take each x coordinate, we have negative 5 and 8. We're going to subtract them, negative 5 minus 8. And then we take each y coordinate and also plug them in and subtract. So 6 minus negative 4. And then if we put it all together in the formula, we're going to start with parentheses and follow order of operations and then take the square root last. So negative 5 minus 8 is negative 13 squared. 6 minus negative 4 is 10 squared. So negative 13 squared is going to be 169 plus 10 squared, which is 100. And if we combine that, we get the square root of 269. And the answer in terms of square roots can be left like that, since sometimes the distance on a coordinate plane is an irrational number, so we can just leave it as 269, the square root of it. So this is our final answer. Now we're going to do the same thing again, and it might help to write the formula over and over here in the beginning, because you're going to do it a bunch of times. So the x's subtract. 4 minus negative 3 squared, plus the y's subtract. 3 minus negative 7 squared, Then we simplify the parentheses. 4 minus negative 3 becomes 7 squared, plus 3 minus negative 7 becomes 10 squared. So you get the square root of 49 plus 100. But again, since this is going to give me an irrational number, a decimal that never ends, we're going to just leave it in terms of square roots. So the square root of 149 is my answer. And then we have the midpoint formula. If you think about the middle point, you're basically going to take two values and divide by 2, or to think of them as half of the distance. So I've put here on a number line what the midpoint formula would look like. You're taking each value at A and B and just adding them and dividing by 2, and that will give you M, or your midpoint. So this is a word problem related to that idea. So if you take the temperature on a thermometer and it's dropping from a reading of 25 degrees to negative 8 degrees, we need to find the midpoint. So, so it's positive 25. And we're adding that to negative 8, and then we need to divide by 2 to get our answer. So we get 13 divided by 2, or 8.5. Oh, not 8.5, I'm sorry. That's not correct. So this is why you always check your work. 25 plus negative 8 is not 13, it's 17. So your answer would be 8.5 degrees. And then the midpoint formula on a coordinate plane is just like it says, the middle point. So it's in point form, x comma y. They label this as M. So we're going to find the midpoint, and we're also going to find, if we're given the midpoint and another point, what would be the other end point. So this we're just using to find the midpoint. The midpoint formula, like I said, is set up as a point. So you have the x coordinates added, divide by 2, and then the y coordinates added, divide by 2. So if you take the x coordinates here for AB, you have 5 plus negative 4 divided by 2, comma 12 plus 8 divided by 2. So it's set up as a point. That gives you 1/2, and 20 divided by 2, which is 10. So that would be our midpoint for AB. We can do the same thing for CD, negative 8 plus 5, the x coordinates divided by 2, and negative 2 plus 1, the y coordinates divided by 2. So you get negative 3 over 2 and negative 1 over 2. And then the last problems, we're going to be finding the missing end point. So we're still going to use the midpoint formula, but we're going to basically use it as a means to solving an equation. So if we're going to find the missing end point of segment EG, it gives us E and it gives us the midpoint M. We need to find G. So what I would do in this case is I would set up the midpoint formula with what I know. So remember, it starts like this. Add the x coordinates, add the y coordinates, and divide by 2. So if I plug in, one of my x coordinates is going to come from E plus x, because I don't know the other x coordinate, and then divided by 2. And then my other x coordinate is going to be, actually, no, let's pause here. So if we just do the x coordinates part, I'm going to take the x coordinate from E, I'm going to add that to the x coordinate from G, which we don't know and we're trying to find, so that's why it's x. And then I'm going to divide by 2, because that's part of the midpoint formula, and put it equal to what my x coordinate is for the midpoint formula, which is negative 5. So if I just solved this like a equation, I would need to solve for x here, so I would need to multiply by 2, and that gives me negative 8 plus x equals negative 10, and then I would need to get 8 away to get x by itself, so I'd add it. So x would be negative 2. So that gives me the x coordinate of G. Now I don't know the y coordinate, but I'm going to do the same idea for the y coordinates. So if I erase this, I get my y coordinate from E, which is 6, plus y, since I don't know the other y coordinate, over 2, and I'm going to put it equal to the y coordinate of the midpoint. So I'm going to multiply by 2. I get 6 plus y equals 20, and to get y by itself I would need to subtract 6. So y would be 14. And that would be my y coordinate of the end point. And I'm going to do this one more time. So you'd take negative 1 plus x over 2 equals 5. Oops, I messed up. M is the midpoint, so I'd need to take 5 plus x over 2 equals negative 1. Multiply by 2. 5 plus x equals negative 2. So x would be negative 7. So that is my x coordinate for E. And now I need to find my y coordinate for E. So 6 plus y now over 2 is equal to the y coordinate of my midpoint. So I'd multiply now by 2 like I always do. 6 plus y equals 6. So I'd subtract, and y would be 0. And that would be my other endpoint. So you see how I can take the midpoint formula and then use that to find different other points. Now, this I wanted to just talk a little bit about a segment bisector. It's kind of like what you'd think a bisector means. So you basically are cutting a segment, a line or a plane in half, but you're having a segment that intersects another segment at its midpoint, and that segment that intersects it is called your segment bisector. So we're going to find the measure of YZ if Y is the midpoint of XZ. So we're going to set this up as the midpoint formula. So if you're going to find YZ, and we have XY, and then we have YZ. What I would suggest here is to draw this out. So Y is the midpoint of XZ. So I'm going to draw XZ, and then label Y as the midpoint. And then I can fill in each part. So it tells me XY is 2x minus 3. So that's this part. And YZ is 27 minus 4x. And so we talked about a segment bisector can be a point, a line, or a plane, and it intersects at the midpoint. So if we think about Y being the midpoint, it's going to separate XY and YZ into two equal parts. So we're going to put them equal to each other here in order to solve for x. So 2x equals 30 minus 4x, and you get 6x equals 30. So x would be 5. Now it says find the measure of YZ. Once I find x is 5, that means we're just going to plug it in for x here. So 27 minus 4 times 5, or 27 minus 20, is going to give me 7 for my answer. And the last one, find the value of x if c is the midpoint of AB. So you're going to do, again, I would always draw a visual, because it's saying that c is the midpoint. And then we're labeling AC as 4x plus 5. And AB as 78. Okay, so what you could do here, you could do two different options. You can either divide 78 by 2 and put that equal to 4x plus 5, because that's part of, or half of the line. Or you could do 4x plus 5, and since the other part is going to be the same, you could do 4x plus 5 plus 4x plus 5 equals 78 and solve that way. I would probably just do half of 78, which is going to be 39, and I would take that and put that equal to 4x plus 5. And solve for x that way. And I end up getting a decimal, but that's okay. So my answer is going to be 8.5. And that concludes lesson 1-3.